Asteroid shock. News shows that Ryugu and Bennu asteroids were formed from destruction of their parent space rock. Asteroids Ryugu and Bennu may both be chunks of the same parent space rock created from a cosmic collision. This is what astronomers have now announced. Mathematical modeling suggests asteroids Ryugu and Bennu, in orbit between Earth and Mars, were once part of a huge parent space rock. Now, new simulations of large asteroid disruptions, such as those that take place in the asteroid belt, show the ejected fragments can actually reaccumulate. The fragments can form aggregates, some of which have a destructive spinning top shape. The simulations show Bennu and Ryugu may have formed from the disruption of the same parent asteroid, despite their different levels of hydration. Scientists believe the overall properties of the asteroids could directly result from the disruption of their parent celestial body. The analysis of return samples from Ryugu and Bennu by JAXA of Hayabusa 2 of Japan and NASA's OSIRIS-REx spacecraft will allow scientists to verify this by precisely measuring their composition and by determining their formation ages. NASA's OSIRIS-REx is scheduled to land on its suspected sister by October 20th to collect further samples, which will also be flown back to Earth. The University of Arizona and Laboratoire Lagrange, Ivory Coast astronomers modeled collisions in the Mars-Jupiter asteroid belt before making the shocking proposal that this could have taken place. The team hopes to measure the composition and age of the formation of these samples from both asteroids to confirm their extraordinary theory. OSIRIS-REx has beamed back striking images of asteroid Bennu's alien surface, revealing its desolation as a lunar surface. The extraordinary images revealed by NASA's chosen landing site, dubbed Nightingale, is located in a crater near the asteroid's northern hemisphere. The spacecraft will remove chunks of about less than an inch in diameter from the asteroid before it heads back to Earth. The Hayabusa 2 of Japan also sent images of asteroid Ryugu's lunar-like surface back in February. The Space Pro's pictures reveal a surprising reddening in some of the rocks. This lead University of Tokyo scientists to conclude the rogue space rock of Ryugu once skimmed close to our sun. Planetary scientist Tomokazu Morita of the University of Tokyo said, immediately after touchdown, Hayabusa 2's thrusters disrupted dark, fine grains that originate from the redder materials. The stratigraphic relationship between identified craters and the redder material indicates that surface reddening occurred over a short period of time. We suggest that Ryugu previously experienced an orbital excursion near the Sun. The Hayabusa key dates: December 3rd, 2014 was the launch. December 3rd, 2015 was the Earth flyby. June 27, 2018 arrived at asteroid Ryugu. And November to December 2019 spacecraft departed the asteroid. And this December of 2020, Hayabusa 2 will bring the asteroid sample back to Earth. This is according to an Express UK article by Tom Fish. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you. Surprisingly, we found a narrow zone of collapsed rock hiding within the broad caldera at Santorini. Geological studies of the eruptions at Santorini had not led us to expect there would be a confined volume of rocks in the northern part of the caldera that sound traveled through more slowly. Rather, we thought the entire caldera would be filled with this type of broken rock at shallow depths. Our findings meant that the collapsed portion of the caldera was much narrower and deeper than it appears from the surface. This column of disrupted rock is less than 2 miles across, small compared to the size of the 6-mile wide caldera. The structure goes down into the ground 2 miles below the bottom of the bay. These rocks must contain lots of water-filled gaps to have sufficiently slowed the seismic energy we recorded. To figure out how this unique volume of disrupted rock formed, we drew on existing knowledge of Santorini's most recent large explosion, the late Bronze Age eruption of 1630 BC. As magma erupted from the subsurface, it caused the overlying rocks to break up. At the same time, underground explosions fractured the rocks when magma and water came into contact. Then above this collapsed column, the seafloor depression filled with porous volcanic deposits from the eruption itself. Finally, the entire bay dropped down and rapid flooding formed a tsunami wave. What's particularly interesting about our findings is that magma continues to accumulate directly beneath the column of disrupted rock thousands of years after this explosion that originally created the caldera. My colleagues and I think the rising magma comes to a halt beneath the reduced weight of the broken rock in the collapsed column. Our research helps explain how magma systems are reset and regrow after major volcanic episodes. This is on The Conversation.